Our next group of macros are lipids. And again, here is a link to a video clip about lipids. Lipids are commonly known as fats, oils, and waxes. They are nonpolar molecules. And we're going to look a little bit later on in this unit about water and the properties of water. And we're going to discover that a water molecule is polar and lipids are nonpolar. So what that means is they're not going together. So ultimately, we're not going to be able to make solutions out of lipids. And you probably know that already. We already know that oil and water does not mix. Now, for these lipids, they are commonly known as fats. So I always like to joke and tell people that this is one of the easiest ones to remember because if you think about it, if I ever win the lottery, which I don't play, so it's impossible for me to win it. But if I ever win the lottery, then I'm going to go to Beverly Hills and have liposuction. Now, if I go to Beverly Hills to have liposuction, what in the world am I going to have sucked out? My brain? No, I'm going to have my fat sucked out. So liposuction, lipids, it's pretty easy to remember if you think about it this way. Now, the building blocks of lipids are called fatty acids. And again, that's kind of easy to remember, fatty acids, so fat. Now, the functions of lipids. Lipids are known for storing energy on a long-term basis. So fat cells, we know fat cells, adipose tissue, and you can see some of the pictures here. So we're looking at stained cells here. So this is mammalian adipose cells. So this is some mammals' fat or fat cells. And we know what people think about with fat cells. It's something that a lot of people try to get rid of. And again, here we go back to some of that science of dieting. Our first go-to in our body for energy is going to be the carbohydrates. But then there's these fat cells that will also store energy. And not all fat cells are created equal. If you look at this picture, some of them are bigger, some of them are smaller, some of them have more energy stored than others. But basically, if you look at some nutritional packages and you see fat and then you see the calories from fat, there's going to be a big number there from the calories from fat because this fat has more available energy in it. So if we take in fat into our body, then we're going to be making a whole lot more energy than we would if we were taking in something else like protein. So some of the kind of ideas behind some diets, and I keep thinking about Atkins as being one of those where you go low carb or no carb. Well, if I go low carb or no carb, my body still has to have energy. I'm just not going to just pass out and lay there. I still have to have energy. And if I don't have carbs coming in, then the next go-to will be to get some of this energy out of our fat cells. And then that way they will shrink. Now, the only way to completely get rid of them is to have them sucked out with the liposuction, but we can shrink them. Or we could make them bigger, and probably a bunch of people did that during the quarantine. I know I did myself. What are you going to do? Now, when I think about lipids and energy storage, I go to the story of the Donner Party. Now, I'm not going to get into a lot of detail, but I did put a couple of links here. So if some of you are interested in history, and I happened upon this story myself by watching, I can't remember if it was on the History Channel or Discovery Channel, or I don't know what it was on, but it was a story looking at the science behind the Donner Party to try to find some type of artifact, some type of proof that the Donner Party actually did what they're known for. And what they're known for is cannibalism and how they survived a winter and winter storms to move out west during the westward expansion by consuming the flesh of those that had died already. And in the story, they took this poor guy out in the woods and they had him simulate the conditions, the living conditions that the Donner Party would have lived in And what they were looking at this poor guy, they were looking at calories in and calories out. And every day, this poor guy was stuck out in the woods, trying to walk through the snow, trying to gather wood, trying to make a fire. He was in a calorie deficit every day. So, according to this show, anyway, that I watched, that if they did resort to cannibalism, there would have not been any nutritional reason for it because the people would have been starving. They probably would have been emaciated. And that's a word that you hear oftentimes referring to animals that have been abandoned, is that they're emaciated. So that means the body has no carbohydrates, so there's no source of carbs. The body's used up its energy reserves from fat cells, and then it started working on the protein. So emaciated would mean that the muscles are also gone. So they're literally just skin and bone. And they didn't really find any artifacts, any type of physical proof of cannibalism. But I have a couple of little articles here for you to look at. One is from NBC News, and the other one is from the History Channel. Um, this one is 10 facts about the Donner Party that you didn't know. So if you've never heard of the Donner Party, then these are all brand new to you. And then this one is an article where someone's saying, well, hold on a second there. Maybe they didn't do this at all. So I'll let you be the judge of that. The other things that are associated with lipids, your cell membranes. Now, after we finish the biochemistry, we head into cells. The cellular biology will be next, and we will talk about the cell membranes. We'll talk about transport of molecules through the cell membranes. Cell membranes are a pretty big deal, and lipids are a primary component of cell membrane. So what you're looking at here is a cross section of the cell membrane, and it looks just weird. I mean, to be honest, how else to describe it? It looks weird. So it's a series of looks like maybe balloons with a couple of strings. Now, what these balloons with the strings, these primary components of your cell membranes, what they're called phospholipids or phospholipid molecules. And here is the head part and the tails, that's what it's called. This is the phospho part. It's actually phosphorus and glycerol, so it's a phosphate. And this is the lipid part. These are the fatty acid tails. And what we're going to learn about as we go through polarity is that polarity has a whole lot to do with how molecules are arranged and to making sure that nothing is going to be repelled. And that's the way your cell membrane works. So we'll see in a little bit more detail when we get there that these lipids are nonpolar. They don't get along with water, so they have to be on the inside of the cell membrane. Got a little bit of information here, a little FYI for you when it comes to saturated versus unsaturated fats, and it might be something that you've looked at or heard about in the past. But when I look at this, one of the key things I kind of take from this is the difference between HDLs and LDLs. So I don't know if you've had your cholesterol tested or not, but if you haven't, you will. And usually you'll get some printout and you'll get a number, and then you'll get your level of LDLs, your level of HDLs, and then the ratio between the two. So LDL stands for low density lipoprotein. And if you look, these are actually what people call bad cholesterol. So it's coming from these fats that are solid at room temperature. So think about butter. These are the artery cloggers. Then we have the HDL, which stands for high density lipoprotein. Even though it's high, this is actually the good cholesterol. So this is kind of one of those opposite days thing is bad is low and high is good. And these are the ones that are liquid at room temperature. So even if your cholesterol is high, I've always been told that if you look at your ratio between the goods and the bads and you have more good than bad, then you're still okay. I guess I'm not okay because last I had my cholesterol done that my numbers were so off that I couldn't even get a ratio. So I don't know what that's supposed to mean. I'm doomed, I guess. And a couple other ones I'm just kind of throwing in there, a little FYI. Myelin is a phospholipid that insulates nerve cells. So we're talking about your brain. So we are fatheads. I've never been called a fathead, but you know. So what you're looking at here is a neuron, a nerve cell. So we have dendrites receiving signals, the cell body there with the nucleus, and then the axon where the signals are sent out. And then this, it kind of looks like sausages, or maybe like those little things you put on your pencil, those little gripper things. That is the myelin sheath, and that helps the signal to go by faster. So people have multiple sclerosis, an autoimmune disorder. So autoimmunes mean something's wrong, the body's attacking itself. Um, it actually goes after the myelin sheath and causes it to harden, and then therefore the signals do not go as fast as they should. Not a good deal. Lipids also act as chemical messengers. They're used to make hormones, and hormones travel to different parts of the body to make things happen. And most of the times when people are talking about lipids and chemical messengers, they're talking about estrogen, testosterone. And you know, you've heard of both of those, estrogen, testosterone. We have both of those in our body. Males have more testosterone and females have more estrogen. And then to look at some examples, the energy storage, also we can think about insulation. That's with our fat cells, cell membranes, fatty acids, and cholesterol, not cholesterol. I picturate the L. There it is. Uh, so we'll see as we look at the cell membranes are called fluid mosaics, or the fluid mosaic model. And when you think about mosaic, you think about all these different pieces of glass, all these different colors. And the mosaic, when it comes to the cell membrane, are all of the different types of molecules in the cell membrane. So there are the fatty acids, there's the phosphate heads, there's cholesterol, there's protein, there's some carbs. So there are a lot of different types of molecules there. And this cholesterol, this is structural cholesterol. This is cholesterol we need. This isn't the type of cholesterol um, that the Honey Nuts Cheerios bee is trying to work against. That's not that type of cholesterol. And then the chemical messengers, steroids and glycolipids. So glycolipids, and you could see it there, this little chain of carbohydrates sticking off of one of the phospholipids, and they're just a part of this cell-to-cell communication. So yes, your cells communicate with each other. They don't text, but they do send chemical signals.